Okay, so we'll do vector first, then we'll do that error in measurement. That's second part of the dimension chapter. Okay. So the vectors have definite magnitude. Like scalars as well. Definite direction. And can be added with the laws of vector addition. Here, we term those quantities as vectors which are having definite magnitude and definite direction definitely. Apart from that, we can add those quantities with the help of laws of vector addition. Okay. So just to mention few laws of vector addition. Parallelogram law. Triangular law. Polygon. These are the laws, and apart from this, we have one method called component method. Component method of vector addition. So by these principles and component method, we can add vector quantities. Okay. So when we say the vector quantity, that is definite magnitude direction obviously there. Apart from that, they can be added with the laws of vector addition. Means you can apply the law addition principle to add them. Clear? Now representation of vector. That to differentiate it from the scalars, an arrow is given at the top of it. So whenever you get a letter along with an arrow at the top, it means it is representing a vector quantity. Clear? So A along with this arrow represents a vector quantity. Now, when we just need to refer to the magnitude of the vector only. So we do it with the letter only or modulus sign. So when you get this modulus A vector or just the letter itself representing a vector, we are actually referring to the magnitude of the vector. Clear? So only letter A written or the modulus sign written means we are not bothered about the direction. It is just the magnitude which is referred to. Clear? That is modulus A or just the letter. Okay. Now in geometry, vector is represented by an arrow-headed straight line. In geometry, vector is represented by an arrow-headed straight line. Here. like this. This, say that is representing a vector A. Okay. So the magnitude is represented by the length and direction by the arrow. So this arrow suggests the direction and the length of the straight line represents the magnitude. That is how we represent a vector in geometry. Clear? How? Let us see. Say two forces are there. F1, that is say 10 Newton. Say rightward. Or F2, 15 Newton upward. So what I do, I select a scale. Say 5 Newton is represented by 2 centimeter. I choose a scale of this. That 5 Newton in the geometry would be represented by a 2 centimeter long straight line. Here. Then to represent this F1, I should represent it with 4 centimeter long straight line. And F2 with 6 centimeter long straight line. Clear? That is how we represent the magnitude of the vector in the geometry. We choose a scale because the vector can be anything. It can be force, it can be acceleration, it can be any other vector. But length means always in centimeter, meter like that. So we choose a convenient scale. Why do I say convenient? Suppose I got two forces. F1 is say 100 Newton and F2 is say 150 Newton. So if you choose this small scale, then the straight lines will be too long. You cannot accommodate it in your copy also. So what we do, we prefer that say 50 Newton is represented by 2 centimeter or 1 centimeter. I choose a scale like this for this. So this will be a 2 centimeter long straight line and this will be a 3 centimeter long straight line. Clear? So the convenience is one thing that to be taken care of. Whenever some quantities are given as vectors and you want to represent that in the geometry, so choose the scale conveniently. Clear? So regarding the magnitude part, that is okay. How we choose a scale? Now regarding the direction, say it is rightward, it is upward like this. So these arrows will guide you about the direction. A man is moving due east. So the due east direction would be given by the arrow. Clear? For example, you are representing vector quantities. So you show us diagram like this. This is north, this is east. Now it is mentioned a boy is moving due north. A boy is moving due west. A boy is moving northeast. A boy is moving making 30 degree with northeast. 30 degree with north towards east. So like this. So these arrows will be giving the directions of the vector. Here. So the length represents magnitude with a proper scale, and arrows give you the direction. Here. That is how we represent vector in geometry. Okay. We are up to this. ঠিক আছে? So now unit vector. I just introduce it for now because this will be studied in details later. Unit vector, from the name only, it is clear the magnitude would be unit 1. If it is mentioned to be unit vector for any given vector, the magnitude will be 1. Here. So unit vector means by default the magnitude is 1. It is used to describe direction of a vector. The utility is to represent the direction. How do you obtain it? It is obtained by dividing a vector with its own magnitude. Here, if you divide a vector with its own magnitude, that gives you unit vector. Okay. Any vector, suppose 5 Newton force. If you divide it with 5, what do you get? 1 Newton. 100 Newton force divided by 100. So if you divide any vector with its magnitude, that gives you the unit vector for the given vector. So mathematically, how we write it? Any unit vector is written by a cap or a hat. We pronounce as a cap or a hat. Both are okay. So this is a unit vector for a vector A. So suppose this is a vector A. You are dividing it with its own magnitude. So magnitude of a given vector is modulus A. So vector A divided by modulus A. That gives you the unit vector for the A. And how to write it? A cap or a hat. Clear? Now, as I stated that it is used to describe direction. Suppose this is F1. Whatever be the magnitude, you don't bother. Suppose this is a vector F2. This is a vector F2. So F2 is having same direction that of F1. So you say in language like this that the vector F2 is having the same direction that of F1. Now how to write it mathematically? F2 got some magnitude, say it is 15 Newton. 15 Newton. And direction is along F1. So that along F1 is written as F1 cap. Getting the point? You are given with a vector F1. That direction is known to you. Regarding F2, what is stated? that F2 got the same direction that of F1. So how to write it mathematically? F2 equals to some magnitude, say 10 Newton. Direction is along F1. Along F1 is F1 cap. Here. So F2 equals to 15 F1 cap. Clear? That is how we represent the direction of one vector for another vector. Suppose it is given that you are running due east. Your friend is following you. So following you means they also are having the same direction that of you. So that would be written as v cap. Suppose your velocity is v vector. So v cap represents the direction of your motion. Suppose you are running in some direction with some velocity. Your friend pushes you from back in the same direction with 15 Newton force. So 15 Newton is the force applied by your friend. And regarding the direction of that force along your motion, so you write v cap. That indicates the direction of force is along your motion. That along your motion, that language is mathematically represented by the unit vector for your velocity. বুঝতে পারলি? Here, so unit vector is used to describe any direction. So magnitude 1, তার মানে multiply করছিস means there is no change in the magnitude part, because you are multiplying with 1. That does not change the magnitude of the desired vector. It is only giving you the idea of the direction. So unit vector is used for describing the direction. And how we get it for a given vector? Simply you divide the vector with its own magnitude. You get the unit vector. Here. And there are 3 standard unit vectors. Is x-axis, y-axis, z-axis. So direction along x-axis is represented by I cap. Along y-axis represented by j cap. Along z-axis represented by k cap. Here. So I cap, j cap, k cap. These are 3 standard unit vectors describing directions along x, along y, along z. Standard. Whenever you see something I cap, means that is along x-axis. Clear? So we call them orthogonal triads. Orthogonal triads. Clear? Orthogonal মানে হচ্ছে mutually perpendicular. The meaning of orthogonal is perpendicular. Mutually perpendicular. Triads because 3 are there in number. So x and y mutually perpendicular, y and z mutually perpendicular, x and z mutually perpendicular. Clear? So x, y, z are 3 mutually perpendicular axes. So I cap along x, j cap along y, k cap along z. They are orthogonal triads. Okay. Now, equal vectors. Vectors are said to be equal if they carry same magnitude and same direction. Here. Equal means just not to the magnitude. Be very careful. Very casual way we say that they are equal. So for vectors, we cannot say equal, that is equal. If the vectors are having same magnitude, same direction, then they are equal vectors. Only magnitude same. They can't be referred to as equal vectors. They are not. Here. So vectors are equal. So mathematically we write A vector equals to B vector. When magnitude of A and magnitude of B same and direction of A, direction of B same. Understood? Magnitude of A, magnitude of B same. So modulus A and modulus B same. And direction also same, money A cap and B cap same. A cap referred to direction of A, B cap is referred to direction of B. So A cap equals to B cap means what? They are carrying same direction. And A modulus equals to B modulus means what? They are having the same magnitude. Here. In geometry, they must be represented with straight lines. Same length, same direction. Same length, same direction. So A and B are equal vectors. Clear? So on the contrary, if they are negative vectors, vectors with same magnitude. And exactly opposite direction. Vectors with same magnitude and exactly opposite direction. They are negative vectors. A vector is equal to minus B vector. They are carrying same magnitude and exactly opposite direction. Magnitude of A and magnitude of B both are same. For a vector, minus does not mean any change in magnitude. It means only the change in direction. So if the boy is running due east and his velocity is positive, so boy running due west will be taken as negative. So multiplying this with the negative thing means direction is getting reversed. So A and B, they are set like this. A vector equals to minus B vector. It means A and B carrying the same magnitude, but exactly opposite direction. That means A cap is minus B cap. Direction is exactly reverse. In geometry like this. Clear? So negative vectors, vector with opposite direction, same magnitude. Okay. If a vector is multiplied with a scalar, If a vector is multiplied with a scalar, its magnitude gets changed, but direction remains unchanged. Here, if you multiply a vector with any scalar, only the magnitude part gets changed, but the direction remains unchanged. Say this is A. Now you have B, which is lambda A. This lambda is a scalar quantity. Lambda is a scalar. So this is B. That is lambda A. So A and B are carrying the same direction. Only they differ in magnitude. The magnitude of B is lambda times that of A. Here. So any scalar. Scalar can be positive, negative, anything. If the scalar is positive, direction is same. If the scalar is negative, direction would be opposite. If the lambda scalar is a positive quantity, positive constant scalar, then direction of A and B would be the same. And if it is a negative scalar, direction will be opposite. Here. So that is how we get the idea of the scalar multiplied to a vector. Means this modulus B is lambda times of modulus A. But A cap and B cap same. Direction same A cap and B cap same. Only lambda multiplied to A. So magnitude has become lambda times. Clear? Just see, if I draw them like this, there is no change. So what I'm trying to say, that when you get a vector multiplied by a scalar, then vectors remain parallel to each other. Or you can even say they are collinear. Because for vector, we have a basic rule called sliding rule. You can slide a vector anywhere without changing the direction. You can slide it to anywhere. Unless you change the direction, the vector is not changed. So if I draw them like this, they are parallel vectors. If I draw them like this, you can say collinear. So collinearity or parallelity, both are same thing. And how to prove that? The vectors are parallel. The vectors are collinear. How to prove it? One vector is scalar multiple of another vector. If you get one vector, scalar multiple of other vector, their direction is not changing. So if the direction remains same, they are parallel. They are collinear. So this collinearity can be checked with this linear dependency. That is, one vector is scalar multiple of another vector. Clear? Kushan, okay?
Yes, sir.
So if you get one vector as scalar multiple of another vector, you can term them to be collinear, parallel, anything. So to check the collinearity, you have to prove this. Suppose you get a vector A, another vector 3A. Are they collinear or not? Yes. Are they parallel or not? Yes. Clear. So if you can prove that one vector to be scalar multiple of another vector, you can say them to be, you can conclude them to be collinear, parallel. Clear. Same direction, same means collinear, parallel, anything can be said. Because the sliding rule you understand now. That vector that can slide coach, I can take it to any position. So they remain same, parallel. Direction same. Or if I take exactly along the same line, I term it collinear. So they are not different things, right? Clear to? So collinearity or parallelity that can be checked. The scalar multiple, that is clear. Collinear vectors. You can say collinear means along the same line, or you can make it more general, they are parallel. Right? Specifically, the word is a collinear vectors means they are along the same line. That's fine. But you can even say them to be parallel. And how to know it? If one vector is scalar multiple of another vector. Okay. Collinear vectors, parallel vectors. Okay. Done. Changing. Co-planar vectors. Vectors lying on the same plane. Vectors lying on the same plane. They are co-planar. Clear. How to prove them to be co-planar? We'll come to that later. After product. After dot product, we'll get to know how to prove vectors to be co-planar. But for now, co-planar means what? They are vectors lying on the same plane. Suppose I give you this XYZ plane, XY space, XYZ space. So XY is a plane. So if you draw vectors in XY plane, all these are co-planar vectors. If you draw them on this YZ plane, these are co-planar. But this plane and this plane are mutually perpendicular. Here. So these vectors are lying on XY plane. These vectors are lying on YZ plane. Clear. So these are co-planars. These are co-planars with amongst themselves. So co-planar means the vectors are lying on the same plane. Suppose on your plane of paper, if you draw vectors, they are all co-planar vectors. Clear? Okay. Now concurrent. Co-planar vectors. Now concurrent vectors. Concurrent vectors. Vectors passing through a common point. vectors passing through a common point. Okay, they are concurrent vectors. Okay. Initial vectors. Co-initial vectors. Vectors originating. Vectors originating from the same point, same initial point. You can also say them to be diverging, right? Vector A and B. They are originating from the same point too. Now the arrow side of the vector is called head of the vector, and the other side is called tail. That means when you say that the vectors to be co-initial, the tails of the vectors are put together. Is not it? When you say the vectors to be co-initial, they are originating from the same point. That means the tails of the vectors are put together. They are at the same point. Then we call them co-initial vector. They are originating, they are initiating from the same point. Clear? Tails are at same point. Now co-terminal vectors. Co-terminal vectors. Vectors terminating. That is converging. At the same point. To the same point. Means heads are at the same point. Heads are at the same point. Both are terminating. The same point too. The heads of the vectors are at the same point. They are co-terminal. Okay. This will study in details later. I just introduce it. Position vector of a point. position vector of a point is obtained by joining origin to the point. Say XYZ and say this is the point A. So position vector for the point A is obtained by joining origin to the point. Arrow should be given from the origin to the point. This is the position vector for the point. Here, origin to the point. The arrow is from origin to the point. That is called the position vector of the point. Okay. Null vectors. Null or zero vectors. Null or zero vectors. Magnitude is 0. No definite direction. No defined direction. Zero vector or null vector means magnitude 0. And as magnitude 0 does not have any existence, so direction is also not defined. It is just a mathematical requirement. When we write this zero vector, is 0 along with arrow, that's zero vector. So it is just a mathematical necessity. That just now what I have said, that position vector of a point is joining origin to the point, right? Joining origin to the point, we get the position vector of a point. So if I ask you, what is the position vector of origin itself? It is 0. That is zero vector. That is zero vector. What's the word? If I ask you the position vector of the origin itself, joining origin to origin means 0. That's a zero vector. Or say you are adding two negative vectors. Say A and B are negative vectors. It means what? A and B are carrying same magnitude, opposite direction. Right? So if you add them, what do you get? If you add A and B, what do you get? 0. Now just see, adding two vectors must not give you a scalar. You are adding A vector with B vector. So you are adding two vectors. You are supposed to receive another vector, but you are writing 0 means you are writing a scalar. So you are claiming adding two vectors, you get a scalar, which is not possible. There is a mathematical ambiguity. Just to overcome that mathematical ambiguity, I can write like this. A vector plus B vector gives you a null vector, a zero vector. Clear? Just to get these situations overcome, we use the concept of null vector or zero vector. It has got magnitude 0, no defined direction. Clear? But then I am compelled to write 0. Because if I write 0, then what actually I am writing? Adding two vectors, getting a scalar. Not possible. A big ambiguity. So I write 0 vector, it's a meaningful thing. By adding any two vectors, you are getting some vector now. That's 0 vector. Clear? Or another example is this position vector of origin. Position vector of origin, that is also zero vector. Adding two negative vectors. Gives zero vector. Okay, Gitanjali. Ramona, okay.
Yes, sir.
Parallelogram law. Say we ought to add two vectors A and B. So mathematical expression should be A vector plus B vector. When you get A arrow, that means vector. So A vector and B vector are to be added. Of course, this is going to be totally different from scalar addition, because in case of scalar quantities, we had only the magnitudes to deal with. But now we have to deal with directions as well. Vectors may have any direction. Between two vectors, the angle can be anything from 0 to 180. So that is to be taken care of while adding. So now we'll learn how to get the vector, single vector by adding two vectors. Here. So A and B are two vectors which are added. So just like any addition, adding two vectors we receive a single vector. Right? Samyukta? Adding two quantities we receive a single quantity. So adding two vectors we receive a single vector. We term it as resultant vector. This R is the resultant of A and B. R vector is the resultant of A and B. You are adding A and B, you are getting the resultant R. Just to get a real situation, you see. Suppose this is a block. Now I apply this with a force A and with a force B. Two forces are applied. What is the net force acting? How to say? The forces are not in the same direction. So it is not going to be just like a scalar addition. It is a pure vector addition. So adding this A and B, we receive a single vector, a single force. We'll learn now that how to receive that force, that single vector. The parallelogram law will enable us to get the single vector obtained, the resultant vector obtained by adding two vectors. Here. So in the diagram, this magnitude of A is represented by the letter A. Magnitude of B by letter B. Magnitude of R by the letter R. These are magnitudes of. Now theta, angle between A and B. Theta is angle between A and B. Clear? So three information are there with you. What are they? The magnitude of A, the magnitude of B, and the angle between the vectors, theta. Three information are given to you. The magnitudes of the individual vectors A and B, and the angle between the vectors. So we have to get this out. So as per the statement, say this is a vector A. And this is a vector B. They can be in any direction. So A and B, these are to be added. So first thing about the parallelogram law is what? The vectors which are to be added, they are made co-initial. Their tails are put together. Here. That means I slide the vectors and I get their tails together. So suppose this is A, this is B. I just get their tails together. This is A. This is B. Here. So that is the first thing to be understood about applying the parallelogram law. The vectors which are to be added, they are made co-initial. Their tails are put together. Clear? So in the process, they become two adjacent sides of a parallelogram. Clear? So now I complete the parallelogram. I complete the parallelogram. This is the parallelogram. Here. So this P, Q, S, T. That's the parallelogram completed. So the two vectors which are to be added, they are made co-initial, and then we complete the parallelogram, making those two sides as two adjacent sides of the parallelogram. So now we get this parallelogram. Clear? Now as per the statement, the diagonal which is originating from the same initial point of the given vectors. This A and B, they are originating from this point P. The diagonal which is also originating from that same point, same initial point, that is the resultant of the given vectors. That means these two vectors will produce the resultant, this one, PS. That means for these two forces, the resultant will be somewhere like this. Here, statement. The two vectors which are to be added, they are made co-initial. Then the parallelogram completed. Then the diagonal which is originating from that same initial point of the vectors A and B, that is the resultant. Here. So that is the statement of the law. So two similar vectors to be added are represented by two adjacent sides of a parallelogram. Making them co-initial. Then the diagonal originating from the same initial point that of the given vectors represents magnitude and direction of their result. Okay. This diagonal originating from the same initial point that represents the resultant, the given vectors. Clear? AB made co-initial, parallelogram completed, draw the diagonal originating from the same initial point, that is the result. Okay. So, modulus A given, modulus B given, angle between the vectors theta given. So now my job is to measure the length PS, because we know in geometry the length represents the magnitude of the vector. So magnitude of the resultant R is represented by PS. This modulus of A, modulus of B and R. So modulus of R is what? Modulus of A, that is given by A in the diagram, that is PQ. Modulus of B, that is B in the diagram, that is PT. And modulus of resultant, the magnitude of resultant, that is R in the diagram, that is PS. My job is to measure the length PS. Then only I can get the resultant by magnitude. Here. And regarding the direction of the resultant, here given directions are A and B. Then the vectors A and B are given to you. So you know the directions of A and B. So to get the direction of the resultant vector, you need to get the angle made by the resultant with either A or B. Any one angle will give you. If you can find out this alpha or beta, then you can get the direction of the resultant as well. Means suppose here two forces, I get to know this angle. So I know the resultant by direction. And regarding the magnitude, the length of the straight line PS. Clear? In the diagram, length represents magnitude. Clear? The job is what is to be done, that is clear. The magnitude, that means for that length PS to be measured, and for direction this alpha or beta to be measured. Okay. Okay. So AB parallelogram completed. P Q S P A Q theta. Resultant R. Now construction perpendicular dropped from S on extended PQ. Make it at M. This is extended PQ. Perpendicular is dropped from S. This is M. This is M. Okay. So this theta angle, this angle and this angle same for parallelogram. Now if PT is representing P, then QS is also B. Opposite sides of the parallelogram. Clear? So this QS is B because PT is B. Now this is theta, this angle is also theta. So in this right angle triangle, QMS sin theta, MS by QS. Okay, sin theta is MS by QS. And MS equals to QS is B sin theta. Any doubt? Clear? MS is B sin theta. Now cos theta. Cos theta. QM by QS. So QM is equal to QS is B cos theta. So MS is B sin theta, QM is B cos theta. Clear? So now let us get into this right angle triangle. PMS, PM square. This PS is hypotenuse. PS square equals to PM square plus MS square. PS square equals to PM square plus MS square. Pythagoras. So PS is resultant R only. PM, that is PQ plus QM, right? PQ plus QM whole square. MS. Now PQ is A. QM is B cos theta. Now MS is B sin theta. Okay. So R square is obtained. So R would be square root of, I break this square, A square plus 2AB plus B square cos square theta. This one is B square sin square theta. So under root we get A square 2AB cos theta, B square taken common, cos square theta plus sin square theta, which is 1. r equals to root over a square plus is only b square. A square plus b square plus 2ab cos theta. Here, that is the resultant of two given vectors a and b by magnitude. Mone rakhte hobe. And this is the only formula we have in addition. Other than this,
ab cos theta কেন নিচ্ছে?
Square term a square plus 2ab cos theta plus b square cos theta.
So in the second one, only 2ab cos theta.
স্যার উপরে তাহলে ওই cosটা মনে হয় মিস।
Okay. Here. So b square is root over a square plus b square plus 2ab cos theta. That is the magnitude part of the resultant. Information lagche a, b and theta. The magnitude of a, magnitude of b, and the angle between the vectors. Here, these three information are there with you. You can get their resultant. Say 5 Newton force, 2 Newton force, and angle is 60 degree. So root over 5 square plus 2 square plus 2 into 5 into 2 cos 60. That is the magnitude of the resultant force. Here. So we get the magnitude by this magnitude of the resultant vector. Now for direction, let the resultant be making an angle alpha with a. So resultant makes an angle alpha with a. So tan alpha. Tan alpha is ms by pm. Tan alpha is ms by pm. Ms is what? B sin theta. Pm PQ plus QM. So PQ is A and QM is B cos theta. So these are resultant. B sin theta by A plus B cos theta. Tan alpha equals to B sin theta by A plus B cos theta. That is the direction of the resultant vector with A. Here. So that how to remember this formula? The magnitude part is very easy. That is root over a square plus b square plus 2ab cos theta. Regarding the direction, you just look at the expression. I have taken alpha with a. Tan alpha, that alpha is obtained made by this r with a. And in the expression you see, in the left hand side you got tan, in the right hand side also, sin in the numerator, cos in the denominator. Clear? Secondly, see alpha is with a. And you see the other vector b is associated with sin and cos. When you take r to make an angle alpha with a, then in the expression, how to remember that I am saying, as I have taken alpha with a, in the expression what we get? B sin theta by a plus b cos theta. The other vector is associated with sin theta and cos theta both. Here. So when you get the alpha with a, then tan alpha would be b sin theta by a plus b cos theta. For a change, if I had taken the angle with b, what would have been the answer? Without reducing, tell me.
A sin theta by B plus
sin theta by b plus is cos theta.
Because beta is taken with B. So A should be associated with sin theta and cos theta. A sin theta by B plus A cos theta. Clear? So we got the magnitude and direction of the resultant. Okay. বলো এই অবধি কারো ডাউট আছে? ঠিক আছে, ক্লিয়ার তো? এগুলো মনে রাখতে হবে ফর্মুলাগুলো। So that one thing by now is clear. The same magnitudes are given. Say for example 5 Newton force and 2 Newton force. If you change the angle between the vectors, the resultant will change. Right? If you change the theta, the angle between A and B, same A and same B, magnitude by same force, for example 5 Newton and 2 Newton, but their resultant can be anything keeping theta some value. As you change theta, so you get the resultant to change. Clear? So when theta equals to 0 degree, theta equals to 0 degree, what does it mean practically? Say this block is applied with two forces, 5 Newton and 2 Newton. So the block is pushed by two forces from the same side to the same direction. So 5 and 2 Newton are in the same direction. It means the angle between them is 0 degree. Right? Angle between two vectors 0 degree means what? The vectors are directed in the same direction, same way. So A and B are in the same direction. So that is theta 0. So A, B are in the same direction. A and B are in the same direction. Resultant A square plus B square plus 2AB cos 0. Cos 0 is 1. A square plus B square plus 2AB. That is A plus B whole square. That is A plus B whole square. So altogether A plus B. That means when you have the vectors in the same direction, the vector summation becomes a scalar addition. Right? A vector plus B vector. Notation wise you see A vector plus B vector. You are performing vector summation. You want to get the modulus of the resultant. That means R সেটা কত আসছে? Simply A plus B. For example, এখানে 5 and 2. What is the resulting force? 5 plus 2 7. So vector summation behaves like scalar summation when theta is 0 degree. Clear? Clear? And what about the direction of the resultant? এই যে 7 নিউটন ফোর্সটা কোন ডাইরেকশনে হবে? সেম তো, যা 5 আর 2 এর ডাইরেকশন তাই তো 7 এর। So resultant R is along A and B. Resultant R is along A and B. Clear? So যখন দুটো ভেক্টরকে অ্যাড করছিস which are in the same direction, their resultant will also be in the same direction. and it is a plus b. Simply scalar addition. Simply scalar addition a plus b. Clear? When theta equals to 180 degree, A and B are in the opposite direction. A and B are in the opposite directions. They are going to block us. This side a 5 Newton force is applied, this side a 2 Newton force. The forces are exactly opposite. So R A square plus B square plus 2AB exactly opposite মানে অ্যাঙ্গেলটা কত? এটা 180 cos 180 কত? So this becomes A minus B. So আমি precisely এটাকে A difference B লিখলাম. A difference B means whichever is having greater magnitude should be written first. That means in this example, resultant is 5 minus 2 because 5 has got greater magnitude than 2. Here. So resultant is A difference B means A minus B in case magnitude of A is higher, B minus A when magnitude of B is higher. Clear? So A difference B. And what about the direction? R is along the vector with greater magnitude R is along the vector with greater magnitude. Really? So when you have two vectors are in the opposite direction, then the resultant will be acting in the direction of vector with greater magnitude. This R, in this case, the resultant will be this side. 5 minus 2 in Newton. Clear? তাহলে যখন দুটো vector opposite, the resultant is A minus B and the direction is along the vector with greater magnitude. Clear? Clear? Range of resultant. So one thing to by now clear that if you change theta, then the resultant will vary. Now, when theta is 0 degree, that is the maximum possible resultant. With that 5 Newton plus 2 Newton. With these two forces, how much maximum resultant you can produce? 5 plus 2, 7. You cannot have a resultant more than 7 Newton. Like similarly, what could be the least possible resultant? 5 minus 2, 3. You cannot produce a resultant lesser than 3 Newton. Clear? That means for two given vectors, is R max is A plus B when theta 0, R min A minus B when theta 180 degree. So resultant of two vectors can never exceed A plus B or cannot be lower than A minus B. So we call it range of resultant. We call it range of resultant. Resultant will be always in between A minus B to A plus B. That means for that example, 5 Newton and 2 Newton, it should be always in between 3 to 7. It can be lesser than 3. It can be more than 7. 7.1 is not achievable. 2.9 is also not achievable. Whatever be the angle kept in between. But any value from 3 to 7 is achievable. You change theta, you get the resultant to change. And you can have any value from 3 to 7, but not lesser than 3, not more than 7. Clear? We call it range of result. Okay. Now, if theta equals to 90 degrees, that becomes a rectangle. With the resultant. R equals to root over a square plus b square. Because theta 90 cos 90 is 0. Okay. And regarding the direction tan alpha, this is B. Tan alpha is B by A. So that parallelogram becomes a rectangle. Clear? Okay. So tan alpha B sin theta. Tan alpha equals to B sin theta by A plus B cos theta. And tan beta. Tan beta is A sin theta. A sin theta by B plus A cos theta. Clear? Now, I divide this numerator and denominator both by b. So it becomes sin theta by a by b by cos theta plus cos theta. Similarly, here I divide both numerator and denominator by a. Sin theta by b by a plus cos theta. Here. Now say, if I give this condition imposed, that magnitude of A is greater than magnitude of B. So in this context, you remember you can never write this kind of thing. That is purely not permissible. You can never compare two vectors. You cannot say A vector is greater than B vector. You cannot. You can compare their magnitudes, but not as a whole the vectors. মানে কোথাও যদি তুই এরকম কিছু বলছিস A vector greater than B vector, that is absolutely wrong. Here, you can compare their magnitude. The magnitude of A is greater than magnitude of B. That is okay. Their magnitudes are comparable, but not the vectors as a whole. Okay. So I've given you this condition A for greater magnitude than B. That means A by B is greater than 1 and B by A less than 1. A by B greater than 1, B by A less than 1. Here. ঠিক আছে? So come to the expression of tan alpha and tan beta. A by B greater than 1. B by A less than 1. So this denominator is more than this denominator. If the denominator is more, the fraction is less. So for this condition, tan alpha is less than tan beta. Any doubt? A greater than B, then A by B greater than 1, B by A less than 1. So this denominator is more than this denominator. তাহলে as a whole fraction কি হয়েছে? Decrease করে গেছে। Tan alpha less than tan beta. Clear? Any doubt? Now tan alpha less than tan beta. That 0 থেকে 90 ডিগ্রিতে tan theta value increase করে। Tan 0 0. Tan 30 degree 1 by root 3 increased. Tan 45 degree 1 further increased. Tan 60 degree root 3 further increased. So as you increase theta, tan theta increases. So tan alpha less than beta, that concludes this alpha less than beta. Clear? Tan alpha less than tan beta, so alpha less than beta. Keep it up. Resultant will make smaller angle with the vector with greater magnitude. এখানে A আর B এর মধ্যে কার ম্যাগনিটিউড বেশি? আর কোন অ্যাঙ্গেলটা লেসার? তাহলে R is closer to A. Here. So resultant of two vectors makes smaller angle with the vector that is greater magnitude. Here, যার ম্যাগনিটিউড বেশি তার সঙ্গে স্মল অ্যাঙ্গেল করবে। Okay. So if their magnitudes are equal, then equal angle করবে। How much? If the angle between A and B is theta, then
theta by 2.
so if modulus A and modulus B are same, alpha equals to beta equals to theta by 2. Alpha equals to beta equals to theta by 2. Here, resultant of two vectors. If resultant of two vectors is perpendicular to one of the vectors, resultant R the A or B resultant to. So R is perpendicular to A. Kati pare? This is A. And resultant is obtained to be perpendicular to. R is making 90 degree. R is perpendicular to A. So first thing to that very clear, the angle between two vectors must be obtuse. যদি resultant তো সবসময় ভেতরে থাকবে, so A is this way and B is this way, possible? But B must be on the other side. Is not it? The angle between the vectors কিরকম? Must be obtuse. Resultant তো দুটো ভেক্টরের মাঝে কোথাও থাকবে. So you have said resultant is perpendicular to A. That means clearly B is on the other side of R. So angle between A and B must be obtuse. ঠিক আছে? So angle theta between A and B must be obtuse. Angle between A and B must be obtuse. Here. No doubt nahi to. So this is the parallelogram. This is B. So resultant makes 90 degree with A. So tan 90 degree. Tan 90. Formula 90 with A. Tan 90, 90 with A. So B sin theta by A plus B cos theta. তাই তো? Clear তো? তাহলে লিখি আর this is B sin theta by A plus B cos theta. দেখতো কারণ এটা নিয়ে প্রবলেম হচ্ছে কিনা? আর ঠিক আছে, কি নাম তোর? অর্ক, ঠিক আছে এটা ক্লিয়ার? tan 90 B sin theta by A plus B cos theta. What is the value of tan 90? Undefined. So tan 90 means definitely this denominator is 0. Otherwise not possible because B sin theta is finite. So A plus B cos theta, that must be 0. Otherwise ki possible? No. So cos theta is how much? Minus A by B. If you know the ratio of A and B, you get the angle. যতটুকু বললাম A and B হচ্ছে 1:2, তাহলে A by B হচ্ছে half, the minus of theta 120 degree. Clear? So when it is mentioned that the resultant is perpendicular to any one vector, then we get this A plus B cos theta to be 0 and we get the angle theta. ঠিক আছে? Clear? Clear? This is okay. Now for vector subtraction, we have no separate law. With the help of vector addition only we subtract. So, say you have to perform A minus B. That gives you a resultant of, as usual. If you subtract two quantities, you receive a single quantity. So similarly, A minus B gives you 1. So this A minus B can be rewritten as A plus minus B. Can we do it mathematically? So instead of reading the situation as A minus B, we rather prefer to read it as A plus minus B. That means instead of A subtracted B, we think this way: A is added with the negative vector of B. We know negative vector. B and minus B, they are negative vectors. So B and minus B both carry the same magnitude, only they differ in direction. If B is due east, minus B is due west. So suppose you are given with two vectors A and B, right? So the angle between A and B is theta. So minus B, this one. So this is minus B. So if the angle between A and B is theta, what is the angle between A and minus B? Minus theta. So once you get this thing, ignore B, forget about B, as if you are not given with. Simply remove it. So you got A and minus B to be added. Clear? So you complete the parallelogram, you get their resultant. You get their resultant. So regarding the magnitude part, no change. A square plus B square plus 2AB. The angle is 180 degree minus 3. just make a note. Please don't write this cos 180 minus theta as minus cos theta. Don't. Simply 180 minus theta would be some angle. কেন বলছি দেখ? Suppose angle between A and B is 120 degree. So what is 180 minus theta? So put 60 degree here. তাহলে এটা minus দিয়ে চলে আসবে, যেটা থাকবে না। So simply angle is not theta, it is 180 minus theta. So put everywhere where you have theta, instead of the angle between A and B, you rather put A and minus B angle. Clear? So similarly, resultant makes alpha with A. Then formula wise, tan alpha equals to B sin 180 degree minus theta divided by A plus B cos 180 degree minus theta. Understood? So that's how we get tan alpha and tan beta. Understood? তাহলে যেখানে থিটা আছে, থিটা হচ্ছে অ্যাঙ্গেল বিটুইন এ এন্ড বি গিভেন, তো প্রথম কাজ হচ্ছে আগে বি কে ভুলে যায়, এ আর মাইনাস বি এর মধ্যে অ্যাঙ্গেলটা দেয়, পুট দ্যাট অ্যাঙ্গেল এভরিওয়্যার, বিকজ ম্যাগনিটিউড অফ এ এন্ড বি তো ইজ নট চেঞ্জড, বি or minus b carry the same magnitude. Clear? So only in place of theta, the angle between a and b, it is angle between a and minus b. Okay, that is the vector subtraction, nothing else. Same, everything same. Okay. Done. That's it. Triangular law. Simply remake সঙ্গের মতো, nothing new, only a minor constructional difference. এরকম দেখ, আগে বোঝ তারপর লেখ। In case of parallelogram law, the vectors to be added were represented as co-initial. দুটো ভেক্টরকে টেনে এনে ওদের ইনিশিয়াল পয়েন্টকে সেম করেছিলাম। Here, from the head of the first vector, the tail of the second vector is started. Means that এরকম ছিল, this is A, this is B, এটা ছিল parallelogram law তে। Now what we do? We draw this. That is the only difference. এটা তো আমরা করতেই পারি, স্লাইডিং রুল ফলো করে ভেক্টর, স্লাইড করিয়ে যেখানে খুশি নিয়ে যায় একই থাকে। সো এরকম ভাবে যখন দুটো ভেক্টরকে দেখাচ্ছি, then closing side means tail of the first vector and head of the last vector, they are connected. That is the resultant. This is the resultant. বুঝতে পারলি? দেখ এটা কোনো আলাদা কিছু কি, if I draw this, it is the same parallelogram law, তাই না? সেম প্যারালোগ্রাম law, কোনো সেপারেট ফর্মুলা পাবো না। কোনো সেপারেট ফর্মুলা পাবো না, সেম। তবে যদি এ আর বি এর মধ্যে অ্যাঙ্গেল দেখায়, this is A, this is B, you extend this, this is theta, the angle between A and B. বুঝতে পারলি? তাহলে ট্রায়াঙ্গুলার লতে কোনো ডিফারেন্ট কিছু নেই, আর সেম ফর্মুলা। দেখ তুই যদি এখানে ডিডিউস করতে চাস, ইউ ড্রপ আ পারপেন্ডিকুলার অন দ্য এক্সটেন্ডেড লাইন, একই ডায়াগ্রাম পেলি না? দেখ খেয়াল করে, এটা A, এটা B, this is B sin theta, this is B cos theta, resultant আর কি হবে? A plus B cos theta whole square plus B sin theta square, same thing. Clear? So we are actually going to do the same thing. This is one vector. This is another vector. From the head of the one, the tail of the other started. Just as shown. So we technically say the vectors are taken in the same cyclic order. Right? In this case, they are taken anti-clockwise. Anti-clockwise. So closing side, third side, in the reverse cyclic order. So that is the statement given. That two similar vectors to be added are represented by two sides of a triangle. Taken in same cyclic order. Then the third side taken in reverse cyclic order. Reverse cyclic order represents the magnitude and direction of air result. Two vectors in the same cyclic order, closing side in the reverse cyclic order. এটা গল্পটা বলার জন্য ঠিক আছে অ্যাকচুয়ালি কি from the head of the first the tail of the second to be started আগে যেমন বলছিলাম tails are to be put together, here we say from the head of the first the tail of the second to be started. Clear? That's how we get the resultant vector. Okay. That is the triangular law. No separate formula. আচ্ছা এটা একটা জিনিস খেয়াল করে নাও say I draw two vectors like co-initial or co-terminal. So angle between A and B, this angle, যদি এটাতেও দেখি I extend this angle means this angle. So basically দুটো ভেক্টরের মধ্যে angle means what? Angle between two directions, তাই না? আমরা বলছি দুটো ভেক্টরের মধ্যে angle. So actually we refer to what? The angle between two directions. So direction of this one and this one. So this angle. Now for a change, like this case, triangular law. Say you got a vector drawn like this. Which is the angle between these two vectors? You simply extend the first. then only you can get the angle. Understood? দুটো ডাইরেকশন তুই দেখ খেয়াল করে এটা এ ছিল এটা এ ছিল I rotate it like this. So from A to this. So this angle means the exterior angle to be shown. Here. So angle between two vectors when they are co-initial or co-terminal, it is easy to understand. But when head of one and the tail of the other is at the same point, this angle, the exterior one. বুঝতে পারলি? Clear? তাহলে এখানেও অ্যাঙ্গেলটা কোনটা? এক্সটেরিয়র। এটা A, এটা B, this is theta, this is R in the reverse cyclic order. The reverse cyclic order মানে basically joining tail of the first to head of the last. ঠিক আছে? ক্লিয়ার সবাইকার? তাহলে একবার ফটফট করে খাতাটা খুলে ফেল দেখে নে কি কি করলাম। So vector quantities got magnitude, direction, and they can be added with laws of vector addition. The different laws of vector additions are there. So we have learned parallelogram and triangular law. In the next class, polygon and component method. So now we have learned how to add two vectors or how to subtract two vectors. So here what is left? Getting the position vector of any point in terms of ijk. Then resolution of a vector, just reverse thing. এতক্ষণ কি করছিলাম দুটো ভেক্টরকে অ্যাড করে we get a single vector. That is just the reverse. One vector given resolved into two. That is resolution of the vectors. After resolution of vector, component method of vector addition. And then product of the vectors. Then we'll be done with the vector algebra part. Then application of vector will be there in kinematics. Throughout. Henceforth, the significant change in the physics proves what you're expecting. Everywhere you will be getting vector. Everywhere you will be getting calculus. Everywhere you will be getting trigonometry, coordinates, everything. So we are in that mathematical tool part. Here. So vector বাকিটা একটু দেখে আসিস। So application class একটু question আমরা করে নেব। খুব বেশি কিছু না। বল।
স্যার তাহলে প্যারালেলোগ্রাম ল আর ট্রায়াঙ্গুলার ল দুটো আলাদা করার দরকার কি পড়বে? মানে একই তো জিনিস মোটামুটি।
মোটামুটি না একই জিনিস so far as two vectors are concerned. যখন more than two চলে যাব তখন এইটুকু ফ্লেক্সিবিলিটি আনার জন্য অনেক বেশি সিস্টেমেটিক হয়ে যাবে জিনিসটা। বুঝতে পারলি? সরিয়ে দেওয়ার জন্য অনেক কমফোর্টেবল হয়ে যাব আমরা, which is usable in graphical methods. ঠিক আছে?
আচ্ছা।
If theta is 30 degree, then range will be from A plus B to A minus B also.
না থিটাকে তুই স্পেসিফিক করে দিচ্ছিস তো সেইটা করিস না। থিটার ভ্যালু তো যা খুশি হতে পারে। যা খুশি মানে 0 থেকে 180 সব কিছু। যদি 0 হয় তাহলে সবচেয়ে বেশি, যদি 180 হয় তাহলে সবচেয়ে কম। আর তুই যদি স্পেসিফিক করিস 30 তাহলে তো √a² + b² + 2ab cos 30। ঠিক আছে? স্পেসিফিক ভ্যালুতে তো স্পেসিফিক ভ্যালু তুই পাবো, স্পেসিফিক অ্যাঙ্গেল। কিন্তু যদি যা খুশি অ্যাঙ্গেল দিই তাহলে ভ্যালুটা ওর মধ্যে থাকতে পারে। দ্যাট ইজ রেঞ্জ, মানে প্রবাবল ভ্যালু, প্রবাবিলিটি আছে যা খুশি হওয়ার a - b থেকে a + b। a + b এর চেয়ে বেশি হবে না, a - b এর চেয়ে কম হবে। তুই যদি স্পেসিফিক থিটা দিস তাহলে স্পেসিফিক ভ্যালু বার করবি। ঠিক আছে?